Hi everybody. So here we've got a question on conic sections. So we're told that the parabola C has this equation, and the distinct points P and Q lie on C, and that the tangent to C at P and the tangent to C at Q meet at this point. We've been asked to show that the area of a triangle PQR is 1331. So because we've got a parabola with this equation, I'm going to sketch this graph. And we're told that there's distinct points P and Q, where the tangent to C at P and the tangent to C at Q meet at point R. And we know R is in the third quadrant over here, because X is negative and Y is positive. So I'll sketch all of this. Okay, so because we've got the tangent of P, I'm going to find the equation of this line by differentiating this to get the gradient and substituting in our X and Y values. And then we can do the same for the tangent through Q. So I can differentiate this implicitly. So we get 2y dy by dx equals 16. And then we can move the 2y to the right-hand side and we'll simplify. And then we're told here that the y value is 4p. So we'll substitute 4p in here. And this will give us dy by dx as 2 over p. So now we'll use the equation of a straight line. So I've taken these x and y values from this coordinate. Then we'll move the p over to this side and we'll expand that by 2. So at this point, we've been told that the point R lies on this line. So we can substitute in x equals negative 28 and the y equals 6. Now we've got this quadratic, which we can make equal 0. And when we solve this, we get p equals 7 and p equals negative 4. So now if we were to do the same for the tangent through Q, we would get the same equation, but in terms of Q. So Q would equal 7 and Q would equal negative 4. So we need to find out which of these solutions matches which point. We know that p must be equal to 7 because the p squared would be 49 and 4p would be 28, which is positive. If you were to have p as negative 4, then this would have been negative 16 when it's clearly positive. And if p equals 7, then q must equal negative 4. So now I can sketch this graph again with these values substituted into each coordinate pair. And now we need to find the area of triangle RPQ. Well, we can find this using the cross product of vectors. We know the area of PRQ will be 1/2 of RP crossed with RQ. We can work out RP as 49 take away the negative 28 and the 28 take away the 6. So RP will be the column vector 77, 22. For RQ, we'll have the 16 take away the negative 28 and the negative 16 take away the 6. Then this will be the column vector 44 and negative 22. So when you cross these together, we get 0 for the I, 0 for the j, and negative 2662 for the k. But when we take the magnitude of this becomes the positive, then we'll multiply it by 1/2, and we'll get the area of 1331, as we expected. Okay? Well, thank you very much for watching. I hope you found that useful. If you did find that helpful, please like and subscribe, and you can download the lessons on this topic from my website, mrmathematics.com. I'll leave a link in the description below.